Hi, everyone. This is the presentation from 3D Imaging and Image Analysis team. This is Dina Hu, a senior from computer engineering.
I'm Connie Can, first year engineering.
And I'm Duncan Van, and I'm a sophomore in electrical engineering.
So I'll briefly introduce our project goal. So the purpose of our project is to automatically classify the gesture of a human hand in American Sign Language from letter A to letter Z as shown in the picture on the right. So our algorithm is to given a hand image that it can tell which letter is showing to us. So our first step of the project is to train the image. Given a hand image, then we will make it put it into the MediaPy library, which is a very powerful library that can recognize the hand and draw the hand landmark. So we can use this library to draw the hand landmark as shown in the figure on the right. And we label every joint with a number, and this number help us find the relative joint location that will help us further identify each letters and classifications.
The second step in our project is to remove the background. At first, when we train our image, it turns out that the noisy background really affects the training result. You can see that in the first row, the tips and the palms are not properly located by the MediaPy library. So to solve this problem, we usually tend to convert the background into a pure color so that we can clean the background. And basically, we have two methods to solve this. The first one is to manually remove the background with the use of PowerPoint, Photoshop, and some other kinds of open softwares. But this one is quicker, but we still wanted to do something automatically. So we tried to use MATLAB to generate a binary image. This idea is that we average the RGB values of the whole pictures and make it to a threshold. And then we run through every pixel in the image, and if the image has the RGB value that is greater than the pixel, we will turn it into white. Otherwise, we will turn it into black. So you can see that there's an image on the second row that is white and black. This one is a binary image, which only contains zeros and ones. So after we generate this one, we can use it as a mask to clean the original image background. So the result, we can see that on the second row, the left one is the clean one we done with a binary image. And the one in the last row, we can see that that one is a noisy image before we remove the background. And it can turn out that the training result is better. So far, this is what our team have done for removing the background.
So after we have already get a clean background and a very good training result, we will do the rotation. Because we want to make sure that fingers on the image are pointing towards the left, we need to include an auto rotation algorithms. The idea is that we draw a line between the 0.0 and 0.9, which is indexing on the image on the right. So this line, I suppose it will be a very center line of the palm, and we actually indicate the directions of the finger. So line 90 slope will indicate the direction of the fingers and I can rotate it according to it. After make sure that the finger is pointing towards the left, then our algorithm can starting to work. But one of the problem is that rotation will change the image size. But currently, this problem hasn't yet affected our further algorithm, so I think it will be fine.
So the fourth step is the identification, and the purpose of identification is to classify the hand image to an ASL letter using the location of the joints. So you can see in the picture, in the example, that's a Z hand, and it's placed on the Cartesian XY plane, ranging from 0 to 500 in the Y direction and 0 to 600 in the X direction. And each of the red dots have its own coordinate plane or coordinates. So after the joint is assigned with the coordinate, it's then classified through a Python function, which first identifies whether it's a left hand or right hand, because both hands will have different combinations of joint locations. So after it identifies whether it's a right hand or left hand, it goes to classify and look at the unique combination of joints, and then finally assigns it to a letter. And each letter has its own written function to match the hand. So if this is a Z hand and it's right hand, it will match with the Z hand, and it will not match with any of the other letters.
So our current result is that we are able to distinguish almost 26 letters already, but there will be some confusion between two similar letters such as M and N, which actually are different only in how curved a forefinger is, and P and Q, which is not really good for recognizing in the palm facing towards us angle. So the huge limitation is that our algorithm is limited to only one angle, as I have already mentioned. So this is the very huge limitation we will further want to solve. So if it is possible, we will want to find a way that we can have more angles rather than just one, or if it's possible, we want to raise our 2D recognition to 3D image recognitions. So that's all. Thank you.